everyone, I am Swetashree. Welcome to the YouTube tutorial SNEB'S Biology. Today in this video lecture, we are going to study about the diffusion pressure deficit that is related to the plant-water relationship. Okay, so today we will discuss about different type of pressures that are the osmotic pressure, what is Turgor pressure, what is diffusion pressure. तो आज हम लोग ना एकदम से प्रेशर के बारे में डिस्कस करेंगे, ठीक है। तो माइंड में प्रेशर लेने की बिल्कुल भी जरूरत नहीं है, प्रेशर हम लोग का स्टडी में है, तो हम लोग डिफरेंट प्रेशर के बारे में स्टडी करेंगे। आपका बस एक ही काम है, जल्दी से जल्दी शेयर कर दीजिए वीडियो को विथ योर फ्रेंड्स, like this video and don't forget to subscribe the video so that we will get more updates. So let's discuss the process DPD or diffusion pressure deficit. Diffusion pressure deficit. Okay. So the term or the concept, or we may write it as DPD in short form. So the concept of diffusion pressure deficit was first found by Mayer in the year of 1938. Clear? He used the term diffusion pressure deficit or DPD to represent the concept of water movement. Water movement. Okay. DPD was first used by Mayer in 1938. He used the term to represent the concept of water movement. So let's see what is the actual definition of DPD. It is nothing but the difference, note down, difference of diffusion pressure, okay, I write as DP, or diffusion pressure between the solution and its pure solvent at a particular atmospheric pressure and temperature. Okay, so the definition of DPD is, it is nothing but the difference, it is the difference of diffusion pressure between the solution, mark the point, the solution and the pure solvents. So let's see what is a solution, what is a pure solvent. In our previous class, I said that solution is nothing but the mixture of, or we may say the combination of both the solvent and the solid. So let's see what is the, how is DPD formed? What is difference between the solution and the pure solvent? Let's see an example. See, if there are two systems or two compartments, compartment A and that of the compartment B. In compartment A, there is a pure solvent. Okay. In compartment B, there is a solution inside it. So, in the first compartment or compartment A, the water potential of pure solvent is equal to 0. In our last class we discussed, in solution, the water potential is always negative. Here we consider as -1. Okay. So, in pure water, what happens? The water molecule are always higher. In solution, the water molecule are always less in number, or we may say less in amount. So, in water potential, what we study? We study that the water always move from their higher concentration towards a lower concentration. So, in this case, the water always move from compartment A towards the compartment B. Okay, so diffusion pressure deficit is what is the amount of deficit in the compartment B, or we may say in a solution. How the amount of deficit of the diffusion pressure occur in the solution? Another example, if here the diffusion pressure, we may say it is a difference. So here if dP, diffusion pressure, is equal to 20, here the diffusion pressure is equal to 10, supposed, then diffusion pressure DPD is equal to the difference. So the difference between 20 minus 2, 20 minus 10 is equal to 10. So the diffusion pressure deficit of this solution is calculated as solved as 10. Okay, clear? So here is another point, that is, note down this line, in order to remove the deficit, the solution absorbs some water. Okay, this is called as the absorption of water by the solution, or we may say the capacity of the solution, termed as either absorption of water, which we discussed in our next class, absorption of water, or suction pressure, represented as SP. Okay, so in order to remove the deficit, ये जो डेफिसिट अभी आया है, इसको रिमूव करने के लिए हम लोग क्या करेंगे? The solution absorbs some water. In order to remove the deficit, the solution obviously absorbs some water. This is nothing but the absorption of water, which we discussed in our next class, the next part of our prime-total relationship. That is the absorption of water, or it is called as the suction pressure, represented as SP. So now come to the mathematical representation of diffusion pressure deficit, or DPD. How mathematically it will be written? Mathematically, DPD, that is the diffusion pressure deficit or suction pressure, is equal to OP minus TP. So now come to know what is OP and what is the TP. OP is the osmotic pressure. Clear? And TP is the Turgor pressure. So let's know what are these two, what are the new terms, what is the osmotic pressure and what is the Turgor pressure. Osmotic pressure is the pressure that develops due to osmosis process. We study in our last videos what is osmosis, diffusion, all about this. So osmotic pressure is the pressure develops by osmosis. And come to the TP, that is the Turgor pressure. What is Turgor pressure? Turgor pressure क्या है? इसका एग्जाम्पल एक लेते हैं. Suppose there is a cell. Okay, this is a cell. Then these are some water molecules. Water molecule. When the water molecule enter into the cell by the process of end osmosis, then what happens? It creates some pressure. As the water enter into the cell, then after some time it creates pressure inside the cell. Due to the pressure, the cell increases in size. This is known as turgidity of the cell. Turgidity of the cell. Pressure that develops due to turgidity is called as Turgor pressure. Pressure that develops due to turgidity of the cell is called as Turgor pressure. Clear or not? Okay. As the water enter into the cell by the process of end osmosis, then it creates pressure inside the cell. This pressure increases the size of the cell, swelled up the size of the cell. When the cell swelled off, then it is called the turgidity phase of the cell. Due to turgidity, the pressure that developed inside the cell is called as the Turgor pressure. Mark T for turgidity, T for Turgor. Okay, turgidity hai means Turgor pressure hai. Then another point is that if it is a cell, then it has some cell wall. It is the cell wall. I write CW. Then as the pressure inside to outside move, there is some pressure from the wall also occur into the inside of the cell. Okay, see here, these are the pressure that develops from the wall of the cell. That is called as another point, that is called as the WP or wall pressure. Okay, so the TP is equal to, we may write WP. These are equal and opposite in nature. Equal and opposite in nature. So here it is the mathematical representation of DPD. So here we may write as TP और WP भी लिख सकते हैं. ठीक है, क्यों लिख सकते हैं? क्यों लिख सकते हैं मैं आपको ये बताइए अभी कि ये जो TP और WP है, ये दोनों क्या है? ये दोनों इक्वल एंड ऑपोजिट है. So we can write here WP also. Clear? What is osmotic pressure? What is Turgor pressure? This equation is comes under your short question. Okay, so note this point. Next comes to the two cases of DPD or diffusion pressure deficit. Okay, we see two cases. What are the events occur in that two cases? In the first case, see here I write, this is the case 1 and this is the case 2. Okay, here we consider a turgid cell, and here is the flaccid cell. Let's draw diagram for the two. It is the case 1 and it is the 2. Okay, turgid cell. See, it is a cell. Okay, this is the cell wall. This is the cell and this is the cell wall. Okay, so as the water enters through the osmosis, and we may say end osmosis, particularly end osmosis, water enter into the cell, then it creates some pressure inside the cell. that is called as the Turgor pressure or TP, and the pressure that enter into the cell is the osmotic pressure, that is by the osmosis process. Okay, so in the turgid cell, here it is a condition, that is TP is always equal to OP, that is Turgor pressure is always equal to the osmotic pressure. In your it is the first case. In our second video we discuss some mathematical question also about this, the case 1 and the case 2. Today we discuss only the formulas. In our next video I explain you some of the mathematical question also. Okay, it is the case 1, the turgid cell. If your question there is a turgid cell, then there is always TP is equal to your OP. Then come to the flaccid cell. See, it is a cell, it is flaccid. Okay, squeeze. Then here water only enter through it by the osmotic pressure or OP, but there is no Turgor pressure. There is no Turgor pressure. Mark the point. There is no Turgor pressure. If the Turgor pressure is there, then it is turgid, not the flaccid. It is flaccid means there is no turgidity. It is squeezed cell. So in this case, the TP is always is equal to 0. Okay. Then what will be the DPD? We know that DPD is equal to your OP minus TP. If the TP is equal to 0, OP is equal OP minus 0, then DPD is equal to your OP. Okay, it is a formula. It is a formula. Here I write again. In your flaccid cell, your DPD is equal to OP. And in this case, your DPD is equal to OP minus TP, and in this case OP is always is equal to your TP. Okay, this is the point. In case 1, in turgid cell, OP is equal to 2P. In flaccid cell, TP is always 0, then the DPD is equal to your osmotic pressure or OP. Okay, then comes to here. If I suppose OP is equal to 5 and your TP is equal to also 5. We know that OP is equal to TP. Okay, so OP is equal to 5 and TP is equal to 5. If I put in the formula, then DPD is equal to what? 5 minus 5 is equal to 0. Okay, this formula OP minus TP, 5 minus 5 is equal to 0. So in turgid cell, DPD is always 0. Note this point. DPD always 0, and in flaccid cell, DPD is equal to OP. That is the osmotic pressure. Okay. So this is about today's class. Today we discuss about the diffusion pressure deficit, the osmotic pressure, Turgor pressure, and in our next video we will discuss about some question answer. Okay. क्वेश्चन आंसर भी तो इम्पोर्टेंट है, बस नोट लिखने से तो नहीं होगा ना, क्वेश्चन भी हम लोग को चाहिए, एग्जाम के लिए प्रिपेयर करना है क्वेश्चंस भी, तो वो क्वेश्चन हम लोग नेक्स्ट वीडियो में देखेंगे। ऐसा कुछ स्टूडेंट भी हैं जो बोल रहे थे कि मैम एनिमल फिजियोलॉजी के ऊपर में भी वीडियो करवाएं। भाई जरूर करवाएंगे हम लोग, हमारा तो काम ही है आप लोग को, हम लोग वीडियो सप्लाई करेंगे और कंसेप्ट क्लियर करेंगे आप लोगों का। बिल्कुल टेंशन मत लीजिए, आपका बस एक ही काम है, वीडियो शेयर करना है, लाइक करना है, एंड डोंट फॉरगेट टू द सब्सक्राइब बटन, प्रेस द बेल आइकन। ओके, and there is another good news for all of you students. SNEB'S biology starts the online coaching classes from 3rd August 2020. So जल्दी से जल्दी रजिस्ट्रेशन कीजिए, ब्रोशर हम लोग का डिस्क्रिप्शन में है। If there is any problem or you doubt, then contact us through the mail ID given in the डिस्क्रिप्शन बॉक्स। ओके, आपको कोचिंग क्लासेस में नोट्स मिलेगा, लाइव ऑनलाइन क्लासेस, देयर इज सम एमसीक्यूज बेस्ड क्वेश्चन आल्सो फॉर प्रिपेयरिंग फॉर योर एंट्रेंस एग्जाम्स। ओके, एंड द कोचिंग क्लासेस इज स्पेशली फॉर द 12th board and the graduate students graduated for the 3rd sem and the 5th sem 12th बोर्ड में है आप लोग का, तीनों है बोर्ड्स, आईसीएसई, सीबीएसई एंड स्वेटश्री। ओके, सो जल्दी से जल्दी सब्सक्राइब कर लीजिए स्नेप्स बायोलॉजी चैनल को एंड प्रेस द बेल आइकन सो दैट यू विल गेट मोर अपडेट्स। थैंक यू।